Hello Rishika, if you have joined, please write something in the chat box. Hello Rishika, good evening, how are you? Today we are going to study investigating reactions, right? In which we will study the basic of chemistry. Hello Rishika, if you have joined, please write something in the chat box. Hello Rishika, good evening. Okay Rishika, so let's start. So Rishika, welcome you for the new chapter, investigating reactions, right? What are reaction? Do you know what are reaction? Do you know what is a chemical? Okay, Rishika, you are able to hear me. Okay, good. So if I say chemical reaction always involve chemical changes, right? We will study how we can identify whether it's a physical change or chemical change. But whenever any chemical reaction takes place, we say that chemical reaction always involves chemical changes. Chemical changes means you can see there will be permanent change in the chemical composition. Like in this case, you can see on the screen that initially we have taken potassium iodide and lead nitrate. Both solution were colorless, but when you are going to mix potassium iodide to lead nitrate solution, will get a yellow color precipitate, right? So we will get yellow color precipitate of lead iodide. Okay, it means after chemical reaction we have received new salt solution. One is the lead iodide, which is available in the form of solid precipitate, and another is potassium nitrate. It means whenever any chemical reaction takes place, new composition will be formed. Means the reactant are going to change into product, and products are going to show entirely different properties from the reactants, right? I told you initially it was potassium iodide and lead nitrate, both were colorless solution, but when you mix them together, you will get a different product, that is a lead iodide, that is a yellow precipitate. So we will discuss in detail, right? But there should be some properties which can prove that the chemical reactions are taking place, right? So we can say, suppose you have seen in this case there is a formation of precipitate. So this is also one of the indication that proves that the chemical reaction is taking place. And if you find there is a evolution of gas, in some cases we will find that if there is a evolution of gas, that also proves that a chemical reaction is taking place, right? And if you find change in color in this reaction, only you can see initially both reactant were colorless solution, but after mixing them together we get a yellow color precipitate. It means we can observe in this reaction there is a change in color. So if you find there is a change in color, then also we can say the chemical reaction is taking place, right? Understood? So if you find change in color, if you find change in the state, if you find there is a formation of precipitate, if you find there is evolution of gas, these all are the characteristics which are going to prove that the chemical reaction is taking place. So generally what happens in chemical reaction? Generally whenever why we need a chemical reaction? You know that there are 118 elements in the modern periodic table. When they combine with each other, they are going to form new product, right? They can form acidic substances, basic substances, neutral, or they can form different kind of salts, or if they are sharing electron, they can form organic compound. It means whenever these 118 elements combine with each other, they are going to form different compounds. Why we require a different compound? Because we know that various manufacturing companies, they employ scientists to invent new material. So how we can get a new material, and why new material is required? Because when we get a new material, obviously new material will have better properties in comparison to the existing material, right? And that's why we always try to find out more no more improved product, right? Sometimes if we are having some products and those are not giving us the satisfactory results, so we always go for the better quality. So how we can get? Obviously the new chemical substances can be formed with the help of chemical reaction. But you can't do chemical reaction in one go. For that you require a certain preparation, because we know that chemical reaction always follows a law of conservation of mass, and the same law which we are going to study in this chapter, right? Okay, Rishika. So we require to know that how much reactant is required in order to make particular product, because there are two laws which you should know. One is the law of conservation of mass, another is law of constant proportion. Because whenever any compound, it means new substances will be formed, they will always combine in a fixed proportion by mass, right? And that laws explain that that law is also known as law of definite proportion, right? And that's why we should know how much reactants are required in order to make particular substance. So we should have that much of quantity. Suppose hydrogen is combining with oxygen, so let's discuss. Just wait for a second, let me reach there. Okay, so I told you we should know the law of conservation of mass and law of constant proportion, because every chemical reaction follows the law of conservation of mass, in which we should know that the mass of reactant should always equal to mass of product. Suppose if we are taking hydrogen and oxygen, right? Suppose if we know that when hydrogen is going to burn in the presence of oxygen, it is going to give us water, right? It is going to give us water. But if you take less quantity, whenever we say the water is going to combine in this, water is having two elements, one is hydrogen and oxygen. You can't make water with a different element, because every time whenever new substance will be formed, obviously the same element will participate for making particular type of substance. Suppose if you are going to form water, you require hydrogen and oxygen, you don't require any other reactants. Now you can see, whenever we see the water formula, they are combining which ratio? 2 is to 1 ratio. It means 2 part of hydrogen and 1 part of oxygen. So you require a particular, in the, suppose you are taking 2 gram of this, right? You are taking 2 gram of this, and how much you require? Suppose we know the oxygen atomic mass, hydrogen atomic mass is 1U, and oxygen atomic mass is 16U. So if we take the ratio proportion by mass, so what is going to happen? What is going to happen? We will get 2 is to 16. It means if you are taking 2 gram of hydrogen, you require 16 gram of oxygen, right? Without six, suppose if you are taking 14 gram, in that case no reaction is going to take place. Okay, so in that case we can simplify this. It means how we can simplify? We can simplify this ratio. If it is 2 is to 16, it can simplify into 1 is to 8. It means what is the minimum requirement of hydrogen? If you are taking 1 gram of hydrogen, you require 8 gram of oxygen. If you are taking 1 gram of hydrogen, you require 8 gram of oxygen. Suppose if it is 6 gram, suppose, and then no reaction is going to take place. Why no reaction is going to take place? Because there is a definite proportion by mass. Whenever the elements combine with each other in order to form particular kind of product, so what is going to happen? They will always combine in a fixed proportion by mass. What is the minimum quantity? In this case, if you are making water, you require minimum 1 is to 8 ratio. What proportion they should combine with each other? Hydrogen and oxygen, in order to make water, they should always combine in 1 is to 8 ratio. Suppose if you are taking 1 gram of hydrogen, you have to take 8 gram of oxygen, otherwise no reaction is going to take place. Understood, Rishika? And now we'll understand the next example also. Suppose we are taking 12, means carbon atomic mass is 12U, right? And oxygen atomic mass is 16U. Okay, so if you are taking 12 gram of this, right, and 32 gram of this, okay, so it means what will be the ratio between carbon and oxygen? So we know that that carbon is only one atom of carbon is there and two atom of oxygen. So when you take the ratio of carbon oxygen, it will be 1:2. And we know that carbon is equal to what? 12. So when you take the ratio 12:32, since there are two atoms, so 16 into 2, 32. So when you take the ratio, what will be the ratio? 3:8. If you simplify this, then this ratio will come 3:8. It means what is the minimum requirement of carbon? If you are taking 3 gram of carbon, you have to have 8 gram of oxygen. Otherwise, no reaction is going to take place. One more thing we can explain, that as per the law of, this explains the law of definite proportion. But when you see this reaction, whether this reaction is following the law of conservation of mass or not. Okay, Rishika. So as per law of conservation of mass, the mass of reactant is always equal to mass of product. We can see the mass of reactant is always equal to mass of product as per law of conservation of mass. Who has given? Then Tony Lavoisier. We will discuss this. Okay. So as per law of conservation of mass, matter can neither be created nor be destroyed. How we can prove that? We can prove by taking the masses of the reactant, and we will measure before the chemical reaction the masses of reactant, and then we'll note down the reading, and then after the chemical reaction we once again will take the masses of the product, and then we will compare. So we will find that mass of the reactant is always equal to mass of the product. But this require one precaution: whenever any gaseous products are going to form, we should always maintain a closed system. We should not allow gases to escape out, then you cannot measure the exact amount of product form. So in that case, we can see when you take a 12 gram of carbon and 32 gram of oxygen, what will be the mass of reactant? Obviously 44 gram. Okay, so what will the, and this can be used as a U also, atomic mass unit. And when you take the mass of carbon dioxide, because this is reactant and this is product. Okay, so these two are reactant and one product is formed after the chemical reaction. So when you take the mass of carbon dioxide, once again 12 plus 32 is equal to 44. So we can see total mass of reactant is equal to 44, U is equal to 44 U. It means total mass of reactant is equal to total mass of product. It means whenever any chemical reaction will take place, it is going to follow two laws definitely. One is the law of constant proportion. It means whenever they will combine in a fixed proportion by mass, means they require a minimum quantity. There could be chances that one reactant may be in a large quantity and other reactant may be in the less quantity. But if they have minimum, they are fulfilling the minimum requirement, then the chemical reaction is going to take place, and the element which is the reactant which is in a less quantity can be treated as a limiting factor. You will be studying in the higher classes. Okay, so we have understood. So let's understand once again. So I will show you. So we have understood this. Now what is happening in this reaction? What are reactant in this case? We can see, just wait for a second. We can see in this what are the reactant. We can see the lead iodide and potassium iodide and lead nitrate. And suppose the total mass of reactant is 30 gram, means we have taken 15 gram of potassium iodide and 15 gram of lead nitrate in this reaction. So what will be the mass of the product? Obviously 30 gram. If the total mass of the reactant is 30 gram, so what would be the mass of product? Obviously 30 gram. It means 30 gram is equal to 30 gram. It means this reaction is following law of conservation of mass. So if you measure the mass of product of the reaction, you would find it was exactly the same as the mass of the reactant you started with. We have started with the 30 gram. Okay, so when you, after the chemical reaction, when you weigh once again, okay, what type of method we are using? So we can, there are various method in the chemistry lab we generally use. Nowadays we are using electronic balance. Electronic balance are going to give us the exact because we are treating reactant in the milligram, very small quantity we are taking. So for that we require a electronic balance, and sometime initially it was physical balance was used, but nowadays in the lab we are using. There is one question in your book that what method you are using for measuring mass of reactant. So in this case we can see that we have to measure the mass of the reactant before conducting chemical reaction. Why? Because we know that matter can neither be created nor be destroyed. It means the mass of reactant will always equal to mass of product. Okay, so we should always understand this. What are the reactant in this reaction? We can see potassium iodide and lead nitrate are the reactant, right? What will be the product? Obviously lead iodide and potassium nitrate. I will write this reaction, just wait for a second. uh, then then in this reaction, how could you find the mass of the reactant is same as the mass of the product? Because before conducting chemical reaction, what we are going to take, we will take the masses of, we will try to measure the masses of the reactant with the help of electronic balance, and then we'll take note down this reading. And then what we are going to do after the chemical reaction, once again we are going to measure the mass of product. So then we'll compare whether both are equal or not, right? And we should always ensure one thing that that we should always, whenever we conduct chemical reaction, if products are in the gaseous form, we should always use a closed system. This law is applicable only in the closed system. If the gases in the product if the gases are there as a product, so obviously they are going to escape out. So we should always take precaution. We should not allow them to escape. Okay, so we have observed during this reaction that the mass is never gained or lost in a chemical reaction. This idea is known as law of conservation of mass. When a reaction happens, the atom or in the chemical are rearrangement. It means we can't say that during the chemical reaction atom of the one element is changing to atom of the another. We can't say कि अगर if carbon and oxygen both are combining, we are getting sulfur dioxide. No, it is never going to happen. We can never say that the atoms of the one element is going to change into the atoms of the next. Just wait for a second, I'll show you. Just wait for a second, I'll show you. See, when we take this magnesium, right, and when we take H2SO4 as a, we can see these two are what? These two are reactants, right? So when this chemical reaction is going to take place, what is going to happen? We will get magnesium sulfate plus hydrogen gas. Okay, so this product is in the gaseous state, so we should always ensure that since the product is in the gaseous form, we should always take a system that where hydrogen gas cannot be escape out. So we should always try to collect this gas in a closed systems, right? So that we should exactly measure the mass of product. Otherwise you will find there will be a error in the, while taking the mass of the product, there will be error. Why error? Because since some of the gaseous molecule may be lost in the atmosphere, so we should always take a precaution that, right? Now we can see this in this reaction, these are what? Products, right? And as per the law of conservation of mass, total number of the atom both sides are always equal, right? So we can see how many atoms are there on the reactant side. We can see magnesium is one atom on the reactant side, and product side also one atom, right? We can see hydrogen, there are two atoms on the reactant side. In the product side also there are two atoms of hydrogen. We can see there are two atoms, and this side also there are two atoms, right? We can see there is a sulfur, sulfur in the reaction only one, and this side also one. So once again we are going towards what? We are going to prove that this reaction is following the law of conservation of mass. We can see there are four atoms, this side also four atoms. Yes or no, Rishika? So we can see both side number of atoms are same. That's why the total mass of reactant will always equal to total mass of product. It means number of the atom on the reactant side and number of atom on the product side of each participant or each element will be equal. Always equal. It is not going to gain any other element. They are not going to gain any masses or they are not going to lose, right? So it means atom cannot be created nor be destroyed during the chemical reaction. And one more thing, there is only rearrangement of the atom. We can see initially magnesium was alone, but after the chemical reaction magnesium sulfate has formed, right? And before chemical reaction H2SO4 hydrogen was in the form of sulfuric acid, right? But after the chemical reaction it is alone, right? So we can see it is only rearrangement after. It means whenever any chemical reaction will takes place, there will be rearrangement of the atoms. And chemical reaction always takes place by breaking up the old bonds and making up the new bonds, right? So chemical reaction always takes place by breaking up the old bonds and making up the new bonds. You can see here what we are doing. I have proved one thing, that there is only the rearrangement of the atom between the reacting substances. We can see in magnesium is displacing hydrogen by donating electron to magnesium sulfate will be formed after the chemical reaction, and the hydrogen will be displaced. It means it will be displaced in the form of hydrogen gas, right? So what is this? There is only rearrangement of the atom. We are not creating any other element. During this reaction, the total mass of reactant is always conserved, right? And when you compare the total mass of the product, it means the masses will always be equal. Yes or no? Okay, Rishika? So let's see. Now we'll go back. Now I will explain you what is actually happening in this reaction, right? So we can see. Now you can see, I will do this question, just wait for a second. First we'll discuss this law. Now we were discussing about the law of conservation of mass. So who discovered this law? Who has given this law? Right? So in 1789 in the France, Antoine Lavoisier, he is a nobleman, statesman, scientist, used one of the first analytical mass balances to prove this law. And it was a very big revelation, because initially no one was there to prove that, right? So Antoine Lavoisier was the first person who has explained this law, and then afterwards Dalton, on the basis of this law, has given one of its postulate, that matter can neither be created nor be destroyed. How he has explained? Because he has used this law. So which postulate of Dalton atomic theory explain this law? That as per the Dalton atomic theory, then Dalton atomic theory was the first atomic theory, right? It was the first atomic theory. And as per Dalton atomic theory, matter can neither be created nor be destroyed. And then because Antoine Lavoisier could not explain this law, but Dalton has helped Antoine Lavoisier law to explain, because Dalton has explained both the law. One is law of conservation of mass, and the second, which I have explained you earlier, that law of definite proportion, which was given by J.L. Proust, right? So he was the known, you know that he is known as father of chemistry, because he made it a quantitative science, right? And if I say, what does the law of conservation state? During any chemical reaction, the metal is neither created nor destroyed, and mass is conserved from reactant to product. They are not going to lose, they are not going to gain any kind of mass during chemical reactions. So therefore we can say that mass of reactant is always equal to mass of product. Yes, Rishika? Understood, Rishika? So what is the law of conservation of mass? According to law of conservation of mass, during any chemical reaction in a closed system, matter can neither be created nor be destroyed, and mass is conserved from reactant to product, and therefore mass of reactant is always equal to mass of product. right? So what does this law really mean? How we can prove this law, right? So we can prove with the help of some numericals. So we can prove with the help of this numerical. Now we can see methane is a hydrocarbon, right? It is a saturated hydrocarbon. Whenever methane is burned in the presence of oxygen, it is going to give us carbon dioxide and water vapor. Carbon dioxide and water vapor. Now, what are the reactant in this reaction? We can see methane gas and oxygen gas both are reactant. And what a product in this reaction? We can see carbon dioxide and water, right? So, we can see now. What does this arrow means? Arrow means what? This arrow means means yield, right? It is going to give us what? When you burn methane and oxygen together, what is going to happen? We are going to get, so this arrow represent the change from reactant to product. Yes, Rishika? So we can see methane gas and oxygen gas both are combining. These two are reactant, and after the chemical reaction they are going to form carbon dioxide and water vapor. These are two products. And how we can separate reactant and product? With the help of arrow. Arrow should always point from which side to which side? From reactant side to product side. So reactant sides are always left hand side and product side is always right hand side. Reactant side is always on the left hand side and product side is always on the right hand side. Now the little numbers, these subscript are showing to what? Tell these subscript are telling how many number of atoms are there. We can see there is only one atom of carbon. We can see there is only one atom of carbon, and there we can see there are four atoms of hydrogen. In this case, 2 twos are 4. It means how many oxygen atom will be there? There will be 4. And there will be one carbon atom and 4 hydrogen atom and 4 oxygen atom. So when you compare on the other side, there is a one oxygen atom, one carbon atom and 2 oxygen atoms are here and 2 from this. So 2 oxygen, 2 means 4, right? And 2 twos are 4. Once again 4 hydrogen atom. So we can see the number of reactants are equal to the number of product. So total number of atom on the reactant side is equal to total number of the product on the product side, right? So this numbers tell us what, right? It means if you take the mass. So let's do with the help of some numericals. So how would you draw this reaction as a particles? So I have told you there was only one. So this is carbon, right? And this is hydrogen, this is hydrogen, this is hydrogen, this is hydrogen. So that's why it is CH4. Understood? And then you can see there are two oxygen molecule. Right, Rishika? There are two oxygen molecule and each oxygen molecule contain two atoms. So this is also oxygen atom, this is also oxygen atom, this is also oxygen atom, this is also oxygen atom. And I have told you how many oxygen atoms should be there. There are 4. One carbon atom, we can see this is only 1, and how many hydrogen atom can be seen? 4. Right? So how we can prove? With the help of, now with the help of these figures, we can prove that the particles are conserved, right? The mass of the particles are conserved from reactant side to product side, because what we will observe after the chemical reaction, that there is no loss of any atom. We have seen there was only one atom of carbon, and this side also one atom. And then we can see how many oxygen atom. So 1 2 3 4. So there are 4 oxygen atom, and we have observed there are 4 oxygen atom, right? Understood? And then how many hydrogen? 1 2 3 4. So once again 1 2 3 4. So how many hydrogen atom this side? 4. So we can prove with the help of this diagram, that the mass of these pictures are showing what? The particle which are participating in the chemical reactions, and how they are going to change. What we have observed during this reaction, there is only rearrangement of the atom. Initially there was these 4 atoms were together. Now you can see that they two atoms of oxygen is attached with this. With the help of covalent bonding, we can see double covalent bond will be present between the carbon dioxide, right? So each carbon atom is going to share 2 pair of electron with 2 oxygen atom. That's why we can see double covalent bond, right, between 2 oxygen atom and carbon, right? So we can see what is the other product. 2 molecule of water is formed. 2 molecule of water means 4 hydrogen atom and 2 oxygen atom, right? So what is all really happen? What is all that really happened to the particle in the chemical reaction? There is only rearrangement of the atom, nothing else. There is only rearrangement of the atom will takes place. Okay, so nothing else is going to happen. They are not going to change from one element to another. The same elements are there on the reactant side, same elements are there on the product side. So there is no change in this. So what is going to happen in the chemical reaction? Actually, what they are doing actually, there is only rearrangement of the atom, right? So can atom of one type to type of change into the atom of another? No. So there is a answer is big no. Why? Because there is only rearrangement in the atom of the reacting substances. There is no change. We cannot say that during the chemical reaction, reactant of the one element is going to change to a product of the another element. No, the same elements will be there on the reactant side as well as product side. Okay, so what is happening actually in the chemical reaction? There is a rearrangement of the atom. Can atom of one type is going to change into transform into an atom of another? No. Okay, so how does this picture shows? Because with the help of this picture we can show the conservation of mass. So why we are studying the law of conservation of mass? So we are showing with the help of this diagrams or pictures the conservation of mass. Understood? So now we can do some with the help of some numericals. So let's take, suppose if we have taken 16 gram of this, 16 gram of methane, right? If we take 16 gram of methane and how much oxygen? 64 gram of oxygen, right? And what mass of the product will be formed, right? So we have to tell what will be the mass of the product. So what is the total mass of this? So 16 plus 64 will be 80 gram, and the mass of product means the total mass of carbon dioxide, and this will be collectively written as a X, the mass of product. So this is the X gram. So we can say 16 gram plus 64 gram is equal to X gram. So means what is the total? 80 gram. So we know that mass of reactant is always equal to mass of product. It means 80 gram is equal to 80 gram. So it means 80 gram is equal to 80 gram. Understood, Rishika? Okay. So let's do some numerical from your book also. If you have reacted 2 gram of hydrogen with 16 gram of oxygen, what mass of water would you get? Right? Very simple reaction. We can solve here only. Right? If you take hydrogen, right, plus oxygen. Just wait. Let me go there. Okay, so I will write here for you. Don't worry. So we can see if 2 gram of hydrogen, suppose this is hydrogen plus oxygen, both are combining together to make water, right? And they are saying if you take 2 gram of this, right, and 16 gram of oxygen, so what will be the mass of water? So what will be the mass of X? Obviously 2 plus 16 is 18 gram. 18 gram, right? It means X is equal to 16 gram, 18 gram. It means 18 gram is equal to 18 gram. It means total mass of reactant is equal to total mass of the product. Understood, Rishika? So very easy. So let's go to next question. So they are saying if you melted 25 gram of ice, what mass of water would you get? Obviously, if you are melting 25 gram of ice and we are changing ice to water, because conversion of ice to water is a physical change. Conversion of ice to water is a physical change, because there is no change in the chemical composition. I have explained you earlier. There is a no, if there is a no change in the chemical composition, it means physical change. If there is a change in the chemical composition, obviously it is a chemical change. So it is a physical change because we are changing ice to water. It means if you are converting, this is H2O, this is in the solid form, and you are converting into H2O into liquid form. So there is no change in the chemical composition, right? And you, if you have taken 20 gram of ice, obviously the what will the mass of X? X is equal to 25 gram. So what will be the answer? How much water, what will the mass of water would you get? Obviously X is equal to 25 gram. Is this a physical change or a chemical change? So let's see how we can differentiate between physical change and chemical change, right? So let's see. Just wait for a second. Okay, Rishika, we have understood one thing, that matter is everywhere. Matter is anything that takes up the space and mass, and matter is constantly experiencing the both physical change and chemical change. But how we can find out whether it's a physical change or a chemical change, right? So they have asked whether it is a physical change because converting of ice to water is a physical change. But how we can prove, right? So a physical change alters the form of a substance but does not change it into another substance. Just now we have seen ice also contain H2O molecule, and when it convert into water, that also contain H2O molecule. So there is no change in the chemical substance, chemical composition. It means it changes its shape or size, or it can change its state, but it is not going to change into another substance. It means it is a physical change. But if you change, suppose if you heat calcium carbonate, obviously it is going to give us calcium oxide and carbon dioxide. Understood? Understood? So it dissolves it, like just now we have seen, if sodium chloride is dissolved in water, it is going, there will be a physical change, right? So suppose if changes its phase, just now we have seen how it has changed its phase. The solid has converted into liquid, there is a change in the phase. If the when you boil water, it is going to form into water vapor, it is going to form into water vapor. So once again it is going to change its phase from liquid to gaseous state, right? Right? So if it condensation takes place, it means condensation means the conversion of gas to liquid. Understood? So these all are what? Example of physical changes. So a physical changes occurs when matter changes its property, but it's not its chemical nature. It means on its physical properties are going to change from solid to liquid, right? But there will be no change in the chemical nature, right? We can see the ice also contain H2O molecule, and then it is going to melt, and then once again we can convert water to ice or ice to water. In both cases there is only physical change, no chemical change is going to take place. Yes, Rishika? So physical properties changes could include a change in texture, shape, size, color, odor, volume, mass, weight, density. These all are physical properties. So we can see if we crush the aspirin, or a boiled egg, these all are physical change. There will be no change in the chemical composition, right? So cutting a paper or cutting a cloth, both are what? It's a physical change because we are not changing the chemical composition, right? So there is no change in the chemical composition. Just now we have discussed, if you take 25 gram of ice, and if it is going to melt, if it is going to melt if it is going to melt, what is going to happen? Obviously it is going to melt to water, and what will be the mass of water? That will also 25 gram. Okay, so if ice is melting into water, so what is going to happen? Obviously it is going to form water, and they both will contain H2O. So it is also a melting of glacier. Melting of glacier is what actually? That is also physical change. Yes, Rishika? Understood? Okay, then sawing wood is a physical change. If you're cutting wood, Understood? And a disappearing puddle. If the puddle is going to disappear, that is also example of what? Because it is going to evaporate, right? The water is going to evaporate because of the temperature. Understood? So you have understood. Dry ice. Dry ice is solid form of carbon dioxide. When it is going to change into gaseous form from solid to gas, that is also physical change, right? That is also a physical change. But whenever you see, like we are studying chemical reaction, wherever you see chemical reaction is taking place, it means the chemical reaction always involve the chemical changes, and chemical changes matter undergoes when it becomes a new or different. Like in physical changes, what we have observed, no new substance will be formed, but during the chemical changes, always new substance will be formed. Obviously, when it burns, obviously when it burns, if paper is burned, it is going to convert into soot. Okay, Rishika? And then temperature changes without heating or cooling. Obviously, if it is an exothermic reaction or endothermic reaction, right? If it changes color, I have shown you the formation of precipitate also. So let's go back to the presentation. So understood? We have understood this now. So let's go back. Now there is another problem which you can solve this if you take 32 gram of methane. Once again, one more numerical related to that. If you take 32 gram of methane, it reacts completely with 128 gram of oxygen. Okay. And 88 gram of carbon dioxide is from how many gram of H2O will form? It means 32 gram. So this is 32 gram. We know that this is 32 gram, and how much oxygen was there? 128 gram. So mass of reactant is 160 gram. Now on the other side, see, since carbon dioxide is from the how much carbon dioxide was formed? 88 gram. Now they are asking what is the mass of water. So we will take the sum of this, that is 160. Then 160 minus 88 is equal to x. So what will be the x value? That will be 72 gram. So what is the mass of water? That is 72 grams. So very easy. If you know the mass of masses of reactant, and if you know if there are two products on the product side, in that case, if you know the mass of one product and they are asking the mass of another product, you can easily calculate by putting them in the formula. A plus B is equal to C plus D. So we know the A plus B masses. We have done this. Suppose this is A. So A is 32 gram, B is 128. So when you take the total, that is 160 gram. And when you take 88 gram plus X, so we can easily calculate with a mathematically. Understood, Rishika? So let's go to the next slide. Now, since we have started with this, so we should know if we see this photo, what are the reactant in this? Obviously, the lead nitrate, you can see both are colorless solution, right? You can see when you mix them together, you can see yellow color precipitate. You can easily see yellow color precipitate is formed. Initially both were, this was a colorless solution, this was also colorless, but when you mix them, what is going to happen? The lead, this it is going to form lead iodide. Okay, the yellow color precipitate, and then you can see a solid separate from the solution during this reaction. That's why this reaction is also known as precipitation reaction, because during this reaction precipitate is formed. If you have taken 15 gram of this and 15 gram of both, the 15 gram of this, so what will be the mass of the product? Obviously 30 gram. Okay, so both are 15 gram. This is 15 gram, this is 15 gram, and when you add them together, what is going to happen? Obviously they are going to form 30 gram. So when you take the mass finally of the reactant, that will be equal to 30 gram. Understood? So what are the product here? Let's see what are the product. Now when you mix them together, initially we have taken potassium iodide, and potassium contain K plus ion. And why we need to take the solution? Because during precipitation reaction there will be exchange of ions, right? and then only this reaction is going to take place. So we have seen there is a K plus ion and I minus ion, right? So what is going to happen when it is going to combine with the potassium lead nitrate? That lead nitrate is PbNO3 whole twice. So that also contain what? Pb2 plus, right? And nitrate means 1 minus. So we can see there are four types of ion. One is the K plus, I minus, then lead is 2 plus, and nitrate is 1 minus. So they will exchange their ion with each other, right? When they exchange their ion with each other, the new substances will be formed. So before mixing, potassium iodide and lead nitrate both are dissociated into their respective solution. So and respective ions will be separated out. We can see here in the potassium iodide, K plus ion and iodide ion is there, Rishika. And this case we can see lead 2 plus and the nitrate is NO3 1 minus. So now they are going to exchange their, when you mix them together, you just see what is going to happen. Now when you mix them together, I told you what type of reaction is going to take place. Precipitation reaction. In this reaction you can say that you can see the lead iodide will be in the form of solid particles. That's why you can see a solid separate out. What is the color of this? Yellow. Okay, so that's why we can see yellow PPT. So what will be the product in this reaction? Lead iodide and potassium nitrate. What were the reactant in this reaction? We can see the reactants were, first was the lead nitrate. These are the reactant, and potassium iodide. So when they combine with each other, they are going to form lead iodide and potassium nitrate. Understood, Rishika? Okay. So now we can see how they are, what type of reaction, how we can write the balanced chemical equation for the same. So 2Ki, why it needs to be in the aqueous form? Because in the aqueous form only they are going to dissociate into ions, and so that they can exchange their ions, right? So we can see how they are exchanging ions, right? K plus I minus, right? Pb NO3 whole twice. So you can see K is going to combine with nitrate, right? K plus, and this is going to combine with this. So they are going to exchange, and that's when new product will be formed. That is PbI2 plus 2KNO3 will be formed. That will be in the aqueous form. But this will be in the solid form. That's why it's solid. This is in the solid form. You can see this is in the solid form. And this is in the aqueous form, right? So what is this? After the chemical reaction, what will be the another product? The lead iodide and potassium nitrate. Okay, so now once the potassium nitrate is formed, you can convert into golden dust, right? You can convert this into golden dust. What is this actually? This is actually, this is PbI2. How we can convert? So we have seen during this reaction precipitate was formed, right? During this reaction precipitate was formed, and this precipitate, when you start warming this precipitate, you can produce golden colored dust from this. Understood, Rishika? So you can prepare gold dust from this, and this is experiment. Generally the people ask you to conduct this experiment. So what we have done initially, we have taken two reactant, right? We have taken two reactant, lead nitrate and potassium iodide. When you combine them together, we'll get a yellow color precipitate. When you would separate this yellow color precipitate and start warming, you will get golden dust from here. Okay, understood? Now, how in the second part of your this, and hydrogen oxygen combine to form water, we have discussed this. This reaction is used to power some spacecraft, right? Spacecraft. Why? Because they are going to use because when hydrogen combusts in the presence of oxygen, so it is going to form water. But this reaction is highly exothermic reaction. These reactions are highly exothermic reaction. So we can see when you take a word equation, how we can, they are going to form So we can write we can write here. So you are taking H2O. So suppose H2 plus O2, and you are going to get H2O. So let's balance this, right? So there will be 2H2, and both are in the gaseous state, right? And initially it will be in a gaseous state, means water vapor will be formed, and once it will be cools down, because this is highly exothermic reaction. During this reaction, lot of heat will be evolved. So this is an exothermic reaction. So we can see there are two atom of oxygen, there are four atom of, right, four atom, and both will combine to form 2H2O. They are going to form 2H2. It means two water molecule will be formed. This is one water molecule, this is one water molecule, right? And there will be another water molecule. It means they are going to form two water molecule. That's where 2H2O will be formed, right? So we can write in the balanced. So sometime it seems the if the mass is gained in the reaction, for instance, if you heat zinc in air, obviously you get a white powder. It means initially you have taken only zinc, but once you this what will be the mass is being added, because oxygen is present in the air. So oxygen which is present in the air going to combine with the zinc. So what will be the reaction in this case? So let's see what all reactions are going to take place. So let's write those reactions. Yes. Now you can see here we have taken zinc plus oxygen, zinc oxide will be formed, right? So what was the initial mass of zinc? Zinc oxide mass they have given 8.1. What is the mass of this? 8.1. But what will be the what will be the mass of oxygen which are going to be added? So in that case, we let's solve this numerical. There is one question from your book, so let's do that. Let me check. So it was 8.1 gram oxygen, 8.1 gram zinc oxide was formed, and 6.5 gram, initially 6.5 gram of zinc was taken. So they are asking what will be the mass of oxygen which are going to add here. So what is the total mass of the product? That is 8.1 gram, and the total mass of zinc was 6.5. So how we can get? Obviously once again, so 6.5 plus x is equal to 8.1. So x is equal to 8.1 minus 6.5. So what will be the mass? Tell me. Yes, Rishika? So what will be the mass of this? This is a question from your book. What is the mass of this? 1.6? Yes, Rishika, you have not given me any answer. Tell me, 1.6 is the correct answer? 1.6 is the correct answer. 1.6 gram. So what is the mass of oxygen? That is 1.6. How you can reconfirm? If you add 6.5 and 1.6, it will come around 8.1 gram. It means our answer is correct, because every chemical reaction follows a law of conservation of mass. And then in the next reaction, they have asked us to write a balanced chemical equation for this. This though we have already done. Okay, so let's go back to the questions. Okay, so the next is write a word equation for the zinc, and with that we have already written 2Zn plus O2 is going to give us 2ZnO. Okay, if you made a 8.1 gram of zinc oxide from 6.5 gram of zinc, what mass of oxygen has reacted? Obviously when you minus from the mass of product, so 8.1 minus 6.5, it means 1.6 gram of oxygen was added. Understood, Rishika? Okay. So in other reaction, it can also seems. Now in this reaction, what we have observed, we have taken only zinc, that is 6.5 gram. But when you burn, when you take the mass of the product, so obviously it is going to add, because the reactant is present in the air and it is going to be added, right? So when you take how much oxygen was being added, obviously we have to subtract from the total mass of the zinc oxide. Likewise you can do it for the magnesium oxide also, right? So when magnesium is burnt, right, when magnesium is burnt in the presence of oxygen, it is going to form MgO. But suppose if you have taken only 24 gram, right, if you have taken only 24 gram, but after the chemical reaction, how much oxygen was being added? 40 gram. Suppose 40 gram you have taken, so how much oxygen was reacted in this reaction? Obviously you have to subtract from 40 minus 24. Understood? Okay, so they are asking to write some chemical equation, and as per this, magnesium plus hydrochloric acid. So Mg plus HCl, this is Mg plus HCl is going to give us MgCl2 plus H2. This is the balanced chemical reaction, but we need to write the balanced one. So how we can write the balanced chemical reaction? We can see this is Mg plus 2HCl. So 2HCl AQ, it's going to give me MgCl2 plus H2 gas. Okay, Rishika? Understood, Rishika? So, how would the mass of chemical seems to be changed in this reaction? We can see initially the mass of reactant was less, right? Initially, in this case, this case initially the mass of reactant was less, like in this case also. But after the chemical reaction, mass has increased. It means the oxygen from the, why it is greater? Because oxygen from the air is has combined, and then the new substance which will be formed will have a greater mass, right? So we can see this white powder will have a greater mass. In some reaction, during the combustion reaction, when the oxygen is being added, obviously it is present in the air, so it is going to add. So I told you this law, whenever gaseous products are there, we have to be very careful while measuring, right? Understood, Rishika? So it's time. So I hope you have understood this chapter. Thank you. So I'm going to end my class, Rishika. Okay, Rishika? Thank you. God bless you.